Hi, welcome to A-Level Stats, Year 1, Chapter 6. We're all looking at statistical distributions in this lesson. Before we get started, you're going to really find this really helpful if you have your calculator to hand. So either the two A-Level ones, either the massive one or the smaller one. Just a quick aside, both of them can do everything you need to do, although this one has a few advantages to it that I'll cover basically as I go through it. Okay, let's dive into the chapter. First new thing or thing of note in this chapter is this new notation. So basically what I see quite a lot is the probability of x equals x or x is less than something. Key to remember is that capital X is the experiment. So here rolling the dice is my experiment capital X. And then I'm going to say from this experiment what's probability of getting a result of x. So this lowercase x could be any number. So probability of x equals 3 means you're also rolling a dice and getting a 3. In this case, it is 1 out of 6 because we're assuming it's a fair 6-sided dice. That's basically it. If you're not used to that, it can sort of throw you here and there. I'm going to break this section into 3 parts. First things first, we're looking at probability distributions. Key definition for this is uniform probability. If things are uniform, then all the probabilities are exactly the same. So go back to our dice rolling example. Okay, the roll of each single dice roll was always 1 out of 6, therefore it is uniform. Okay, example questions. You're often given these probability distributions, you have to work some stuff out to do with them. Most of them are fairly basic and fairly straightforward. The ones I want to look at in these few examples all revolve around the fact that all probabilities must add up to 1. The reason this is true is because these are discrete random variables. So by discrete, we used the term earlier, it means it can only take specific values. So for this, whatever it is, we've only got 3 options for the result, either 1, 2 or 3, and we know that all of them must add up to 1. And again, if you want to work out A, you're just going to add all these things together. So adding these together, we work out that A plus 0.8 must equal 1. Again, all of them must add to give us 1. So therefore A is going to be 0.2, and that is not right because that should be a 2A there. So A is actually 0.1. Okay, and that's pretty much it. So new notation I will show you. Often you see this kind of layout as well. So here the odds of getting a result x is A times by that number x. So let's break that down. If you're ever unsure with these questions, you can make a quick little table, and it tends to make it so much easier to realise what's actually going on. So again, I've got 2 options, so I've got 4 options. X can be 1, 2, 3 or 4. The odds of getting a 1 is going to be A times 1, or just A. The odds of getting a 2 is going to be A times 2, or 2A. And then we're going to have 3A and 4A. Here we want to work out the value of A, and we use the exact same fact. There's only 4 possible options, so if you add all these together, it must equal 1, and that's enough for you to be able to work out what A is going to be. Just one more like this. Quite often I like to split it into 2 halves. So here we've got 2 ways to work probabilities based on what numbers we've got. Again, I find it so much easier to work these things out if I just write a quick table. Okay, it does take a bit of extra time and you don't have to do it, but it really does help and make it a bit clear of what's exactly going on. So when x equals 1, I am down this branch here, and it's going to be A times 1 or A. When x is 2, I'm still down this branch, so it's going to be 2A. When x equals 3, we're on this branch now, so it's going to be A times 3, because that's my x, minus 2. So A times 1 or just A. And for 4, it is going to be A times 4 minus 2, which gives me 2A. Then same as before, these are my only options, which therefore means they must all add up to A, and therefore you have enough to work out what A is. Okay, that's the first part. That's fairly basic. That shouldn't be throwing you. What's a bit more involved, and also one of the calculators for, is the binomial distribution. So, binomial distributions have 4 criteria, which I've written down for you here. So for every binomial distribution, you must have a fixed number of trials. We are doing 20 dice rolls, for example. Probability of success must be fixed. It can't change from one experiment to another. So again, 20 dice rolls. Each time we roll it, the odds of getting a 4 is not going to change. Also, you've only got 2 outcomes. You can either succeed or fail. So back to my dice roll, we can say getting a 4 is a success and not getting a 4 is a failure. And lastly, this is the key one they always tend to ask for or relate to in exams. The trials are independent of one another. Okay, so that means if I've got, say I've flipped 10 coins, if I've got 10 heads in a row by pure chance, that doesn't change the odds of my coin being a heads or tail in my 11th throw, which means everything's fair, and whatever ever happens in the past will not affect future throws. That's what independence means. Okay, let's see what they can throw at you. So, we define a binomial distribution in this form here. So you say x squiggle, we're going to have a b for binomial, then you have an n for number of trials, and p for probability. So here, if you're flipping a coin 20 times and seeing how many heads, you would say x is a binomial for b, with 20 trials, and odds of getting a head is 0.5. Just a quick aside, when you get onto year 2, there are other distributions. So you could have x being a normal distribution, with some stuff here as well, and you could also have x being a Poisson distribution with some stuff going on here. But right now, all we care about is binomial, so all you should see in year 1 should be that little b. Okay, let's go through the basic idea, and then we'll sort of show the formula as well, and sort of see how those two stick together. So if I'm to work the probability of rolling 5 dice and getting exactly 1/6, you basically break it down into 2 steps. Step 1, we're going to work out the probability of getting any combination resulting in 1 head. So I could say, not 1 head, 1/6. So I could say I want to get a 6, and then I want to get 4 things that are not a 6. Okay, so x would be any number from 1, 3 to 5. And we can then work out the probability of that. That's going to be 1/6 times 5 6s times 5 6s times 5 6s times 5 6s. And we can compact that a tiny bit by writing it using powers. Okay, that's going to be the first part of our answer. That's one way to get exactly 1/6. We then need to multiply that by the number of ways or combinations you can flip 5 coins. Sorry, roll 5 dice and get 1/6. So basically we can work this out by hand. I've already shown you one up here. I could also get blank 6 blank 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 6 blank blank, and you kind of see that's basically the 6 moving about amongst the not 6s. So altogether we have 1, 2, 3, 4, 5 ways of rolling 5 dice and getting 1/6, 5 different combinations, which therefore means we must times this by 5, okay, to account for each of those different ways. That is the idea of how it works. There is a shortcut for working this out for like any combination, and that on your calculator is basically the choice button. So on a calculator you'll see like an NCR button, and basically we have 5 trials and we want 1 success. So you're typing 5C1, and if I just get a calculator ready, so on these calculators it is shift and divide. On the big ones it is buried in some of the menus somewhere, but I'll let you work that out. And you would just say 5C1. That gives you a 5, which is what you worked out over here. Okay, that's the idea. Let's look at the formula. So in your formula book you were given this, and that is basically the exact same thing that I came to just using logic and common sense. So P is basically your odds of success. So that's each time I rolled a 6. And then 1 minus P is going to be your failure. So again, if the odds of rolling a 6 is 1 out of 6, then the odds of not rolling a 6 will be 1 minus 1 out of 6, which is where 5 over 6 came from. Let's use this, and let's go through a couple examples. So here I've got a random variable where I'm doing 10 trials, and my odds of success is 1 out of 6. So we could say rolling a dice again and getting a 6. Work out the odds of getting 2 whatevers. I just want to have 2 successes. So for here, I know that lowercase x equals 2, because it's always probability of x equals lowercase x. I know what p is, I know what n is, so I'm just going to copy this across, and let's write down what we've got. So this nx stuff, or n2 in this case, that is the same thing as doing NCR I said earlier. So that's basically doing 10 choose 2 on your calculator. Then I'm going to times that by the odds of success. So 1/6 to the power of x. Again, we wanted 2 successes, so it's 1/6 times 1/6 to the power of 2. We then need to times that by 1 minus that. So this is the odds of a failure. And if we succeed 2 times, we must then fail 8 times. And that is all you need to type into your calculator. Okay, I'll just do this one example. So you would say 10 choose 2 times by, we then want 1 6 all squared times by 5 6s all to the power of 8. Okay, and that would be the odds of rolling exactly 2 whatevers. So we'll say 0.291. Okay, and if you wanted 10 successes, you can do the exact same thing. There was a slight shortcut where you could just do 1 6 power 10, but there's no reason the formula won't work. So you can just type in 10 choose 0, which comes out as 1, times by 1 6 to the 10, times 5 6 to the 0. But again, it's worth mentioning, if you can see it, both these terms here will just disappear because they both equal 1. Okay, that's binomial. What we have, which basically adds on to this, is cumulative probabilities. That's we want to work out probability of x being less than or equal to a certain value. Okay, for this, the calculators both handle it fairly well, so do all the work using the calculators rather than by hand or using that formula, which is what you should be doing as well. So let's zoom in on my first example. Work out the probability that we get 3 or less successes using this binomial distribution. For this, you can use either calculator. I will quickly go through it with them both. So it's slightly easier with the bigger ones. So the bigger ones, you want to go to menu. We then want to pick statistics. We then want to go to distribution. We then want to binomial distribution, and we are doing cumulative. So you want BCD. If you're working out one value, it's BPD. But cumulative is 2. Your data can either be a list or a variable. It should always be a variable. Okay. We want to have 3 or less successes. So my least amount of successes, my lower, is going to be 0. The most successes I can have is going to be 3. Number of trials, that's your n. So here n is 15. So I've got 15 trials. And the odds of success is 1 out of 6. And you just type in 1 divided by 6, and this gives us a decimal. We then press this button here, and that'll work it out. So it's 0.7684, yada yada yada. Let's try the exact same thing using the other calculators. So for this, you go to menu. You then want to move across to distribution. We then want binomial cumulative. So you have to scroll down. Always a variable. And then we type it in. X is how many successes we want. We wanted 3 or less, so you put X in as 3. N is how many trials. And P is still 1 divided by 6. And again, you get the same answer. Okay. Really important to mention the difference between these two. The big ones, where they go between any 2 values. The small ones will only let you go for that value and less. So it's a bit more limited, but you can work around it. That we'll see more about in part B. So say for this answer, we had 0.768. Okay, probability of x is less than 4. So here, this is a discrete probability thing. That means we only have whole numbers. So we can't have 3.5 successes. If we're less than 4, that is the same thing as saying we are 3 or less. Okay. So when they ask questions, is often they'll ask it in a weird form, and you have to realise, or have to convert it into a form that you can work out. So again, this we just worked out as 0.768. On something slightly harder. Probability x is greater than 2. Again, we can't have greater than signs, we always want greater than or equal to than signs. So if x is greater than 2, it can't be 2. The first whole number it can be is 3. So this is the same thing as x being greater than or equal to 3. Now for this one, it's significantly easier on the bigger calculators. Let's go back to my variable. Here my lowest was 3. That's the lowest number of successes I could have. The upper, that means everything is going to be a success. So here there's 15 trials, so my upper is 15. And then the rest isn't going to change. Okay, just showing you that again. So when you want to go greater than, you always want your upper to be the same as your number of trials. So that gave us 0.468 round. Now we're going to select problem using the other calculator. Okay, so this calculator will only give us values less than. However, we can still work around it. If we've got greater than or equal to 3, that's the exact opposite of having less than or equal to 2. So instead we have to work this out using the other calculators. We're going to work out what the odds of getting 2 or less, and we know if we do 1 minus that, that will be the same thing as having 3 or more. Let's go for that. You can just go back here, change my x to 2, work it all out. That is 0.5332. And let's see if we can do 1 minus answer. We cannot. Okay. So for this, you have to write this down. So 0.53 and 222. So when you're working out like an intermediate value, it's always handy to get more decimals than you need. You would then have to go off this, go back into math mode, which is 1, and then do 1 minus that number there. So it can be a bit more fussy, but you will come out to the same answer, 0.468. Okay, and that is how binomial works. I'll just go through one exam style problem, and then you have some questions to try that are linked in the description. So on to this problem. We have a telesales representative, and the odds of making a sale is 0.15. So you go through this, it's really handy if you can just sort of jot down the key things and make a note of what they are. So this is my P, this is probability of success. For A, work out the probability. There are no sales made in 10 calls. So here n equals 10. And we can just work that out. We can do that using the formula. So let me go up and actually copy the formula down, if I can find it, which is here. So again, always have the formula to hand, and in exams of course you will as well, so there's no reason not to. We want no sales in 10 calls. That means we want x equals 0, so there's no successes. So we would just type in 10 choose 0. The odds of success is 0.15 to the 0, and that will be times by 0.85, which is 1 minus to the power of 10. Both these two things are going to vanish because they're both equal 1. So all we need to do is 0.85 to the power of 10. So 0.1969. Okay, work out probability that we got more than 3 sales. Okay, so here I'm trying to work out the odds that x was greater than 3. Again, it said more than, so that means we don't have an equal sign here, just a greater than sign. This is going to be the same as having 4 or more successes. And then we can go straight to my big calculator. So we've also got 20 calls, so here n equals 20. Again, you can use an either calculator, but going through here, I want more than 3, so anywhere between 4 and 20. Number of trials was 20 as well. Odds of success, we were told, was 0.15. And there you go, 0.352. Okay, representatives are required to achieve a mean and average of at least 5 sales each day. Find the least number of calls each day a representative should make to achieve this requirement. Okay, so it's basically saying how many calls should you make in order to expect to get 5 sales. So basically you're making n calls, we're going to times that by the odds of making a sale, and we want that to equal 5. Just make at least 5 sales every single day. To do that, opposite of timesing by is dividing. So what we need to do is get our calculator. Again, either one will be fine, it's just one we're in math mode. And we are just going to do 5 divided by 0.15. That gives me 33.3. However, we cannot have a half a sale or a third of a sale in this case, so it makes sense here that we're going to round up. So I'm going to say she needs to make, or he needs to make, at least 34 calls in order to get those 5 sales. Okay, last part. You want to calculate the least number of calls, so we can assume, maybe for the probability of at least 1 sale to exceed 0.95. So this one's worded a bit differently. We're basically working backwards. We want the probability that I make more than a certain number of calls So we need that probability of x to be greater than or equal to 1 to equal 0.95. At first glance this looks horrendous because we don't know what n is. Okay? Typically for these questions you can always do by trial and error. So here I want my lower to be 1. Let's guess 20. And here we worked out it was a 96% chance. And we could then change that. We say, well, what about 19? And you could work it out until it works. Okay, that's because I think it is 19. I'm not going to do that because it might take you ages to figure out what number that is. Okay, so the alternative method is think we could do the opposite of this. Okay, we could know that if the odds of getting at least one call is 0.95, that implies the probability of getting less than one call, the complete opposite, is going to be 5%. Or in this case, he wanted greater than 0.95, so he want less than 0.05. The only way to get less than one sale is to get exactly 0 sales. So you could solve this as well. And the odds of getting 0 sales, that is just 0.15 to the power of n. Okay, and then we have this equation to solve. Oh, sorry, that's not 0.15, it's 0.85, because each time I want to fail. Okay, you've got a choice here. Okay, so you can use trial and error. That gave us n equals 19. And again, you're probably going to check that by putting 18 as well and making sure that it goes down to a smaller number. So in this case, it's gone down beneath 95%, which is why 19 was correct. Or you can work out the opposite, and we get to this equation, which you can solve using logs, which is part of pure maths, so I won't go into it. Both are just as valid, both will give you the same answer. And if you're not sure, I can do 0.85 to the power of 19, and it will be just less than 5%. Okay, and again here you could try an error as well. Okay, sorry, that's it with the example. Some questions to try. I hope that was helpful, and good luck.